Good morning, students. Today we are going to learn about Laplace transform of integral of a function. So from this class we are going to cover in this class two concepts, and from these two concepts you will get 5 marks, damn sure. So what we covered? We covered the definition of a Laplace transform. After that, the 8 standard formula of Laplace transforms. Then we given a linearity property, the problems on linearity property, first shifting theorem, problems on first shifting theorem, chain scale property, problems on chain scale property, second shifting theorem, problems on second shifting theorem, unit step function and its Laplace transforms. Then we went for multiplication by t and t square and division by t. This is what we covered. So today is the last class on Laplace transforms. So, uh, so let us move on. What is a Laplace transform of integral of a function? So, Laplace transform of integral of a function. Sometimes question comes for 3 marks. So what it says, you see, if L of f of t is f bar of s, then L of integration 0 to t f of t dt is 1 by s into f bar of s, just 1 by s extra. So that is very simple and you will get 3 marks here. So if L of f of t is f bar of s, then L of integration of f of t, the limits are 0 to t, L of integration of f of t is just 1 by s into f bar of s. Very simple and you can score 3 marks. Are you able to get it? So this is what we are going to cover today, Laplace transform of integral of a function. You will get 3 marks question. Very easy. You just concentrate a single line, a formula like it is. What is that? It says if L of f of t is f bar of s, that is Laplace transform of f of t is f bar of s, then L of integration of f of t is 1 by s into f bar of s. So let us see the problems on this. Very easy. Let us go to the problems. So let us try to finish two concepts here. So first concept is Laplace transform of integral of a function. Only one formula. Now let us solve the problems, then let us go to the next concept. So let me move on to the problems. This is my first problem. Find the Laplace transform of integration 0 to t sin t dt. Very easy to identify. Identification of the problem is important. Which method we have to go? Is it multiplication by t? Is it division by t? Is it a first shifting theorem? Is it a linearity property or a chain scale property or second shifting theorem? So you have to identify the problem. T into function, multiplication by t, function by t, division by t, e power of at or e power of minus at into function, first shifting theorem, constants into function, linear property, like that. So by seeing the problem you should identify which method you are going to apply. So yeah, very easy. What is that you are having? You are having integration 0 to t L of Laplace transform of integration 0 to t sin t dt. So integration Laplace transform of integral of a function. So find f bar of s, then 1 by s into f bar of s gives answer. So what is f of t? F of t is sin t. So L of sin t, that is L of sin a t. L of sin a t is a by s square plus s square. So you see, we need a standard formula in every method, in every concept, everywhere we are going to use the standard formulas. So from the first class onwards I am saying the same thing. You have to by heart, you should by heart all standard formulas, then only we can able to solve the problems. You see here, f of t is sin t. Now L of f of t, that is L of sin t. You need to know the formula. What is that? L of sin a t. What is L of sin a t? L of sin a t is a by s square plus s square. That is L of sin t is 1 by s square plus 1. So this is our f bar of s. Now formula L of integral of f of t, that is L of integration 0 to t sin t dt is, what is that? We have the formula just now we given, it is 1 by s into f bar of s. It is 1 by s into f bar of s. What is f bar of s? F bar of s is 1 by s square plus 1, that is 1 by s into 1 by s square plus 1, that is 1 by s into s square plus 1. So this is our first problem on Laplace transform of integral of a function. Are you getting? So we need to find L of integration 0 to t sin t dt. By seeing the problem, you can identify it is an integral of a function, Laplace transform of integral of a function. So what is f of t? It is sin t. L of f of t 1 by s square plus 1, that is f bar of s. So into 1 by s, that gives answer. So answer is 1 by s into s square plus 1. This is our first problem. Getting, guys? So let us move to the next problem here. So the second problem, find L of integration 0 to t e power of t into cos h t dt. Cos h t dt. So by seeing the problem, you can identify the method as this is finding Laplace transform of integral of a function. Integration is there inside the Laplace transform, therefore Laplace transform of integral of a function. So what is f of t? What is the function inside the integral is our f of t, that is e power of t into cos h t. E power of t into cos h t. So cos h t is multiplied by e power of t. Which method again? The first shifting theorem. So integral of a function, Laplace transform of an integral of function, within that we are using our first shifting theorem. That's why these problems are important in examination. So L of e power of t into cos h t, that is L of cos h t, replace s by s minus 1. E power of at, if it is multiplied by e power of at, replace s by s minus a. Now e power of t, therefore replace s by s minus 1. What is L of cos h t? Now again the standard formula. What is the formula for L of cos h at? L of cos h at. L of cos h at is s by s square minus a square. Whereas L of cos h is s by s square plus a square. But cos h hyperbolic. L of cos h at, L of cos h at is s by s square minus a square. Here L of cos h t. What is L of cos h t? L of cos h t is s by s square minus 1, where s is replaced by s minus 1. So at place of s, now at place of s, you have to write, what you have to write? S minus 1. So you get s minus 1 by s minus 1 by s minus 1 whole square minus 1. A minus b whole square. What is a minus b whole square? A square minus 2ab plus b square. A square is s square minus 2ab is minus 2s plus b square means plus 1 square is plus 1 minus 1 cancel. So our f bar of s is, what is our f bar of s? Our f bar of s is s minus 1 by s square minus 2s. So once you get f bar of s, it is enough. It's very simple. Now just apply Laplace transform of integral of a function. That is L of integration 0 to t e power of t into cos h t dt is 1 by s into f bar of s. We got f bar of s. What is f bar of s? S minus 1 by s square minus 2s. Therefore 1 by s into s minus 1 by s square minus 2s. Take s common, s into s square. The final answer is s minus 1 by s square into s minus 2. This is our final answer. Are you getting? This is the second problem on finding Laplace transform of integral of function. Are you getting? It is somewhat different from the first problem. So in the first problem only simple sin t function here there, but here we are having f of t is e power of t into cos h t. How to? There is no product rule in Laplace transform, but by first shifting, what it says, if a product of function among the product of functions, if one function is exponential, then we can apply, what is that? First shifting theorem. e power of at means s is replaced by s minus a, and e power of minus at means s is replaced by s plus a. Now e power of t means s is replaced by s minus 1. L of cos ht, L of cos ht is s by s square minus a square. So L of cos ht is s by s square minus 1. S is replaced by s minus 1. You get f bar of s is s minus 1 by s square minus 2s. After applying the formula, this a minus b whole square, a square minus 2ab plus b square. Plus 1 minus 1 cancel, denominator it becomes s square minus 2s. Now integration, Laplace transform of integral of a function L of integration 0 to t e power of t cos ht dt is 1 by s into f bar of s. We got f bar of s, just substitute here, you get the answer. What is that? S minus 1 by s square minus s minus 2. Here we took s common, that's why s into s square. So this is our second problem on finding Laplace transforms of integral of a function. So within the Laplace transform we will get integral. That can a trick to identify the method, very easy. If it is multiplied by t, that is t into sin t, for example t into sin t, then it is multiplication by t. Sin t by t, then it is division by t. E power of t into sin t, then first shifting property. 5 into sin t, it is a linearity property. Are you getting? So integration 0 to t into sin t means it is Laplace, finding Laplace transform of integral of a function method. Are you getting? So this is the method we are doing. So we covered two problems. Let us go to the next problem. Very easy method this is. Find L of integration 0 to t e power of minus t into sin t t dt. So this is the third problem of the topic. So what is that? Find Laplace transform of integration 0 to t e power of minus t into sin t dt. So Laplace transform of integration, integral of a function means that comes this method. So what is f of t? Within the integral, what is the function is there, that is our f of t, that is e power of minus t into sin t is our f of t. Now L of f of t, that is L of e power of minus t into sin t. So product of two functions, among them one function is exponential, means it is first shifting theorem multiplied by, that is e power of minus at. If it is e power of minus at, then replace s by s plus a. Now here e power of minus t, therefore replace s by s plus 1, that is L of sin t, where s is replaced by s plus 1. Again, now what is L of sin t? L of sin t is, what is L of sin t? L of sin at formula. L of sin at is a by s square plus s square. L of sin at, standard formula, Laplace standard formula. Can you recall? Can you remember? You should had all those 8 standard formulas to solve the problems very easily. So what is the formula? L of sin at. L of sin at is a by s square plus s square. Replace s by s plus 1. Are you getting? L of sin t. L of sin t is 1 by s square plus 1, where s is replaced by s plus 1. By using the formula L of sin at, L of sin at is a by s square plus s square. Now L of sin t is 1 by s square plus 1. Replace s by s plus 1. So at place of s, you have to substitute s plus 1. So what you get? 1 by s plus 1 whole square plus 1. A plus b whole square. A square plus 2ab plus b square. So s plus 1 whole square is s square plus 2s plus 1. Again one more plus 1, so it becomes plus 2. So 1 by s square plus 2s plus 2, that is our f bar of s. Once we got f bar of s, that is almost the problem completes. So what is our f bar of s? F bar of s is 1 by s square plus 2s plus 2. Now apply the method Laplace transform of integral of a function, that is Laplace transform of integration 0 to t e power of minus t into sin t dt is 1 by s into f bar of s. What is f bar of s? Just substitute f bar of s. So what will get 1 by s into s square plus 2s plus 2. So this is our final answer. So this is the problem we covered. How many we covered? We covered the 3 problems on finding Laplace transform of integral of a function. Are you getting? So in this method, so you see this problem, third problem, what we are using? We are using the first shifting theorem, because product of two functions, Laplace transform of a product of two functions, among them one function is exponential, e power of at or e power of minus at means you have to use first shifting. E power of minus at means s is replaced by s minus a. Now e power of minus t means s is replaced by s plus 1, that is L of sin t. L of sin at formula is a by s square plus s square, therefore L of sin t formula is 1 by s square plus 1. Replace s by s plus 1, we get f bar of s. What is f bar of s? 1 by s square plus 2s plus 2. Therefore Laplace transform of integration 0 to t e power of minus t sin t dt is 1 by s into f bar of s. Now substitute f bar of s. The answer is 1 by s into s square plus 2s plus 2. Are you getting? So this is the third problem we covered. I think it's nothing more in this concept, because nothing is there. Very simple formula. Integral Laplace transform of integral of function f of t is 1 by s into f bar of s. Only one simple formula and very easy one. We covered 3 problems on the concept. I think no need to do many problems in this, because all are similar and all are very easy. So with this only 3 problems you can solve any other problem on this topic. So if a problem comes, it comes for 3 marks in semester end exam, guys. So I think it's enough. We can end this topic here. So let us go to the next topic, finding integrals. Finding integrals using Laplace transforms. Are you getting the difference? Laplace transform of integral of a function. So L of integral of a function. Now integration, you have to find integrals by using Laplace transform. What is the definition of a Laplace transform? By using the definition of a Laplace transform, we were going to find values of integrals. So finding integrals by using Laplace transform, that is our next topic, and you will get 5 marks from that. So yes, at about 20 minutes, within the 20 minutes we covered first topic. Now the next 30 minutes we are going to cover the next topic. So what is our topic and what is that? Let us see. So this is the topic, evaluation of integrals by Laplace transforms. Now we are going to find integrals by using Laplace transform. The before topic is, what recent topic is, we covered finding Laplace transform of integrals. Now finding integrals by using Laplace transform. So evaluation of integrals by Laplace transform. So what is the definition of a Laplace transform? Is f of t be any function, then Laplace transform is denoted by L of f of t, and it is defined by L of f of t is equal to integration 0 to infinity e power of minus st into f of t dt. Are you getting? Integration 0 to infinity e power of minus st into f of t dt. This value is in terms of s. That's why it is denoted by f bar of s. That is L of f of t is f bar of s. By using this definition, this is a definition in a box I written. This is, by using this we are going to find integrals. What is? Just one more time I am repeating. L of f of t, Laplace transform of f of t is integration 0 to infinity e power of minus st into f of t dt. Are you getting? L of f of t is integration 0 to infinity e power of minus st into f of dt, where s is a parameter. So now by using this definition itself, we are going to find what we are going to find. We are going to find integrals, evaluation of integrals by using this definition of Laplace transform method. are getting L of f of t is integration 0 to infinity e power of minus st into f of t dt. Now let us go to the problems. So this is our first problem, you see. So let us quickly do the problem so that we can cover more problems in this video lesson. Are you getting? Is it stop? No. Yes. Let me carry out. So let us cover more and more problems in this video lesson. So let us quickly start the problem. So what I said, so one more time, disturbance came, so let me go to the previous slide. L of f of t is integration 0 to infinity e power of minus st into f of t dt. So by using this definition of Laplace transform is in terms of integration. Are you getting? Integration 0 to infinity e power of minus st into f of t dt. By using this definition only, we are going to evaluate integrals of similar type. So this is our first problem. Problem number 1. Find integration 0 to infinity e power of minus 2t into t cube dt. Here he is not asking us to find Laplace transform. He is asking us to find integration. That's the topic. Unable to get it. The topic is evaluation of integrals by using Laplace transform. So you have to find integral by using Laplace transform. So that's what integration 0 to infinity. So you similar to our Laplace transform formula. What is our definition of Laplace transform? You see, integration limits, you look at the limits 0 to infinity e power of minus st into f of t. It resembles same the problem. So we cannot find all integrals. We can find only integrals which resembles the definition of Laplace transform. So what are the limits? Limits are 0 to infinity. Were in the problem also. Find integration 0 to infinity, and you see the function e power of minus st into f of t. In the definition, what you are having, e power of minus s into e power of minus s. Sorry, let me move on to there. What you are having, you should see the limits. Limits are 0 to infinity, and the function is exponential function into the f of t e power of minus st into f of t. Look at this very carefully. L of f of t is integration limits. What are the limits? 0 to infinity. And what is integrand? It is exponential e power of minus st into function of t, that is f of t dt. So such a type problems, only such same integrals only we can calculate. You see here also. So what you are having? Integration limits, you see limits are 0 to infinity. Again exponential function e power of minus 2t is there into t cube. What is f of t? It is t cube. Are you getting? So very similar type integrals only we can calculate by using Laplace transform. The integral should be very similar to the definition, the standard definition of Laplace transform. Only such problems we can calculate. Are you getting? So you see our first problem here. Find integration 0 to infinity e power of minus 2t into t cube dt. So what we know? We know by the definition of a Laplace transform that integration 0 to infinity e power of minus st into same f of t, what is the t cube, is, what is that? L of t cube by the definition. What L of f of t says? L of f of t is integration 0 to infinity e power of minus st into f of t. At place of f of t, we are having t cube, therefore it is L of t cube. Now use of standard formula, you see in every concept, in every method, wherever what you are getting, we are using the standard formula. That's why I am repeatedly telling you in every video lesson, in every minute, in every concept. What I am telling is that you should buy all standard formulae, the 8 standard formulae, L of K, L of e power of it, L of e power of minus it, L of sin it, L of cos it, L of sin it, L of cos it, L of t power of n. Once you know the formulas, then only you can then had the formulas first, then go to the method, then practice the problems, then do the homework problems, like that. That is a sequence that you should follow always. So what is L of t power of n here? L of t power of n is n factorial by s to the power of n plus 1. N factorial by s to the power of n plus 1. Now L of t cube is 3 factorial by s to the power of 4. What is 3 factorial? N factorial means 1 into 2 into 3 into 4 into 5 into and so on into n minus 1 into n. That is n factorial. So 1 to n multiplication. Now, what is 3 factorial? 1 into 2 into 3. 1 into 2 into 3 is 6. Therefore, 3 factorial by s to the power of 4 is 6 by s to the power of 4. This is L of t cube, that is nothing but integration. What is L of t cube? L of t cube is this. This is L of t cube. Are you getting by the definition? What is L of t cube? Integration 0 to infinity e power of minus st into t cube into dt. Now instead of s, I am writing 2. So what is that? Integration 0 to infinity e power of minus 2t into 2 cube dt. At place of s, we are having 2. So s is equal to 2. 6 by 2 power of 4. 2 into 2 into 2 into 2. 2 power of 4 is 16. 6 by 16, that is 2. 3 ja 2, 8 ja. Answer is 3 by 8. Are you getting? So we can find these integrals, such a type of integrals, by using Laplace transform definition. That integrals should be limits are 0 to infinity and integrand should have exponential. Then only such integrals we can calculate by using Laplace transforms. So evaluation of integrals by using Laplace transform. This is the first problem. It took some more time because it is a new concept, the first problem. So I took more time to explain the very first problem. But next onwards we can move fast so that we can cover more problems. What is the time left, guys? It is 20 minutes. So let us try to cover another 4 to 5 problems so that you can do any type of problems on this topic. Are you getting, guys? So this is my first problem on evaluation of integrals by using Laplace transforms. Take down so that we can move on to the next problem. Yes, this is my second problem. Find integration 0 to infinity e power of minus 4t cos 3t dt. Very first problem, and now the second problem. You see the integral. Which integral we need to find? The integration 0 to infinity. Limits must match. Otherwise we cannot. So same limits. The limit should be 0 to infinity. Find integration 0 to infinity. Integrand. What is integrand? You see e power of minus 40 into cos 3t. The integrand should have exponential, because what is the standard definition of Laplace transform? L of f of t. What is L of f of t? Integration 0 to infinity. Here also integration 0 to infinity. E power of minus st, here e power of minus 4t into f of t dt into cos 3t dt. So f of t is cos 3t, as you know. So same type integrals we can find by using the definition of Laplace transform. Are you getting? So this is what we know. Integration 0 to infinity e power of minus st into cos 3t is L of cos 3t. So at place of f of t, I am writing cos 3t, the L of f of t, now L of cos 3t. Are you getting? L of cos 3t. What is L of cos 3t? L of cos at. L of cos at. What is L of cos at? S by s square plus a square. Right, good, very good. S by s square plus a square. Now L of cos 3t. L of cos 3t. L of cos 3t. S by s square plus 3 square. What is 3 square? It is 9. Therefore s by s square plus 9. We got this. What is that? L of cos 3t. What is L of cos 3t? Integration, what is that? Integration 0 to infinity e power of minus st into cos 3t dt is, what is that? S by s square plus 9. Now at place of s, now substitute 4, s is equal to 4. Then what happens? Integration 0 to infinity e power of minus 14 into cos 3t dt is, at place of s you have to substitute in RHS also 4. 4 by 4 square plus 9. 4 square is 16. 16 plus 9 is 25. Therefore, the value of integral is 4 by 25. Are you getting? Integration 0 to infinity e power of minus 14 to cos 3t dt. Are you getting? Integration 0 to infinity e power of minus st into cos 3t dt is, so this s by s square plus 9. So in that integral we are substituting s value, that is 4. Then you got this integral is equal to 4 by 25. So this is way we find the value of integrals by using definition of a Laplace transform. So remember which integrals we should go. The integrals resembles the definition of Laplace transform. Limit should be the same, 0 to infinity. One function should be exponential as in the definition of Laplace transform. That's what you have to observe, guys, that one. So integrals, we can find those integrals whose limits are 0 to infinity and integrand consist e power of minus of something, that is exponential function should be there. Only such integrals, not all integrals. Some integrals which resembles as a definition of Laplace transform, those values of integrals we can find by using the definition of Laplace transform, but very easy to find the integrals without integrating. Just using Laplace transform only we are able to find the integral values. Are you getting this? This is the second problem on this. So let us move quickly to solve one more. So this is the third problem. Find integration 0 to infinity e power of minus 2t t into sin t dt. So again you see integration 0 to infinity, and within the integrand we are of exponential. So we can go for definition of a Laplace transform. By the definition, what this, instead of e power of minus 2t I am writing e power of minus st, then it becomes at place of f of t we are having t into sin t, there it becomes L of t into sin t. L of t into sin t, how to find? T into sin t means multiplication by t method it is. Multiplication by t. Multiplication multiplied by t means we do derivative. Division by t means we do integration. So t into sin t, that is minus 1 of d by ds of L of sin t. L of sin a t, s by s square plus s square. L of sin t is L of sin a t, a by s square plus s square. L of sin t is 1 by s square plus 1 square, that is 1 square is 1. Therefore d by ds of 1 by s square plus 1. Previously we did this type of problems. So d by ds of u by v method, v into derivative of u minus u into derivative of v by v square, that is s square plus 1 into derivative of 1 is 0. 1 into derivative of s square plus 1 is 2s by s square plus 1 whole square. So minus into minus plus, what is answer? 2s by s square plus 1 whole square. So this is the value of integration. This integration value, what is that? Integration e power 0 to infinity e power of minus st into t into sin t is 2s by s square plus 1 whole square. In order to find the given integral, substitute s is equal to 2. So we get the given integral is equal to 2 into 2 by t square minus plus 1 whole square, that is 2 into 2 4, 2 square plus 1 5 whole square means 25. So the answer is 4 by 25. It is 4 by 25. Are you getting? So this is a problem. You clearly see This is a problem for 5 marks. So what not we are using everything. So we are using definition, standard definition of a Laplace transform, that is integration 0 to infinity e power of minus st into f of t is our L of f of t. We are using multiplication by t method. We are using derivative u by v formula. We are using standard formula of L of sin a t formula. So everything we are using in this problem. That's why such a tough problems comes in examinations. Are you getting those? This is the third problem we covered on this method. So let us move on to the next. Find integration 0 to infinity t into e power of minus 3t into cos t dt. We know integration, now use of definition, integration 0 to infinity e power of minus st into t cos t. At place of f of t we are having t cos t, therefore it is L of t cos t. How to find L of t cos t? It is multiplication by t method. What is L of cos t? That is L of cos a t. L of cos a t, again standard formula, s by s square plus s square. Now L of cos t is s by s square plus 1. So L of t into cos t is minus d by ds of s by s square plus 1. Derivative of u by v method, v into, that is denominator into v into derivative of u minus u into derivative of v by v square. So minus 1 into s square plus 1 into derivative of s is 1 minus s into derivative of s square plus 1 is 2s. Therefore s square plus 1 into 1 minus s into 2s by s square plus 1 whole square. So after simplification we got it is s square minus 1 by s plus 1 whole square. What is this? This is the value of this integral. So this is the value of this integral. What is that? Integration 0 to infinity e power of minus t to t cos t dt is s square minus 1 by s square plus 1 whole square. To obtain the value of given integral, put s is equal to 3. So what you get? Integration 0 to infinity t into e power of minus 3t into cos t dt. So substitute s place of s 3, that becomes 3 square minus 1 by 3 square plus 1 whole square. 3 square is 9, 9 minus 1 8, 3 square is 9, 9 plus 1 10, 10 whole square is 100, 8 by 100. 4 2 ja 4 25 ja, answer is 2 by 25. The answer is 2 by 25. So what all things we are using in this problem? You see, this is a problem which came for 5 marks. You see, find integration 0 to infinity t into e power of minus 3t into cos t dt. So you should first of all observe the limits 0 to infinity as same as definition of a Laplace transform. So you can use a Laplace transform definition. What it says, integration 0 to infinity e power of minus st into f of t dt is L of f of t. Now at place of f of t you are having t cos t, therefore it is L of t cos t. How to find L of t cos t? Multiplication by t method. Cos a t, L of cos a t s by s square plus s square, L of cos t s by s square plus 1. Derivative u by v method, you get this integral value. You got this integral value we got as s square minus 1 by s square plus 1 whole square. To obtain this integral, put s is equal to 3 in above integration. In both sides you get the answer s is equal to 3, therefore it is 2 by 25. Are you getting? So these are the problems previously came for 5 marks. So be careful, listen careful and understand the things, practice the things, then do the homework and then try to understand the concept. Are you getting this? This is the fourth problem we covered on the topic. So remember which integrals we can find those integrals whose limits are 0 to infinity and those integrals whose integrand is one of part of integrand should be exponential, because they should very same integrals which we learned, which we have for the definition of Laplace transform. So these are the 4 problems. All these 4 problems are previously came for 5 marks. So check the time whether can we cover one more. I think yes, another 5 minutes are there. So quickly we can cover one more problem. So try to see can we cover one more problem. As let us go to the fifth problem. Evaluate integration 0 to infinity e power of minus t 0 minus e power of minus 2t by t into dt. So within the integrand, though no exponential, so you can write it as e power of 0 t. E power of 0 means 1. So you can write s is equal to 0. So within the integrand, if there is no integration exponential also, then we can also at last put s is equal to 0 to get the answer. No need that integrand should have exponential. By putting 0 also we can cover. So that's why for that only I am giving this problem. So what is this integral? By the definition of Laplace transform, this is L of e power of minus t minus e power of minus 2t by t. So previous problem multiplication by t, now division by t. In multiplication we did integration, now in division we will do integration from s to infinity. L of e power of minus a t 1 by s plus a, therefore e power of minus t 1 by s plus 1, e power of minus 2t 1 by s plus 2. Integration s to infinity 1 by s plus 1 minus 1 by s plus 2. Integration of 1 by s is log x. So 1 by s plus 1 log s plus 1 minus log s plus 2 from s to infinity. Log s minus log y is log x by y. Therefore log x plus 1 by s plus 2 from s to infinity. If you substitute upper limit minus of lower limit, upper limit causes infinity by infinity, which is undetermined. Infinity by infinity is undetermined. So which causes infinity by infinity? S term. So take s common and cancel. That's what we are using. Previously we came here in division by t. I explained it clearly. So same thing we are doing here. So now infinity 1 by infinity 0, 2 by infinity 0, therefore log 1 minus log of 1 plus 1 by s 1 plus 2 by s. Therefore log 1 value is 0 minus log of s plus 1 by s plus 2 minus of log x by y is log y by x. Therefore it is log s plus 2 by s plus 1. So we got this integral value is we got log of s plus 2 by s plus 1. But what you are having in this integration here, there is no e power of minus st term. So no e power of st term means put s is equal to 0 here. In the what we find this integral, put s is equal to 0, we will get the what the problem given, that one you will get. So now put s is equal to 0, you are able to get it. Put s is equal to 0 in what we find the integral, that integral value, we put s is equal to 0. So left side is, what is the left side? E power of st becomes 0, minus st becomes 1. Therefore integration 0 to infinity e power of minus t minus e power of minus 2t by t is, put s is equal to 0, log of 0 plus 2 by 0 plus 1, 0 plus 2 is 2, 0 plus 1 is 1, 2 by 1. So log of 2 by 1 is log 2. This is our integral value. Are getting? So what is the time left, guys? No more time. So we should finish here. So before that I am seeing one more time, I am showing the slide here. No exponential term in the integrand, but at the last you can put s is equal to 0, so that if you don't have exponential term, then you can put s is equal to 0 to obtain the given integral value. Are you getting? So this is a fifth problem we covered now. So it's a time to end, so that we can end here the class. We covered two topics here. First one is Laplace transform of integral of a function, and second one is, what is the second one? Evaluation of integrals by using Laplace transform, that is definition of a Laplace transform. So these are the two methods we covered in this single video. So now it is a time to give a homework. Let us try to give homework. So don't worry, only one or two problems. So what you have to do, you have to read the method. First one, what is the Laplace transform of integral of a function, that is 1 by s into a bar of s, that is a formula. Read it, remember it, then practice the problem, then do homework problem. Then second concept is evaluation of integrals by using Laplace transform, that is definition of a Laplace transform. By using definition of Laplace transform, finding same type of integrals. We did it about 5 problems. Practice those 5 problems, then try to do homework. So this is a first method, first problem from first method. Find L of integration 0 to t sine 2t dt. What is f of t? Sine 2t. F bar of s is 2 by s square plus 4. Then integration means 1 by s into f bar of s. That is the answer. Very simple one. That is the first method. Next two are the second method, finding integrals by using Laplace transform. Definition of Laplace transform. So find integration 0 to infinity e power of minus 2t into cos t dt. Here it is L of cos t. Find L of cos t, that is s by s square plus 1. Put s is equal to 2, that gives answer. Third problem is find integration 0 to infinity e power of minus 2t into t sine 3t. That is here L of t sine 3t. Find L of t sine 3t. How to find L of t sine 3t? That is multiplication by t means minus of derivative of L of sine 3t. That is minus of d by ds of 3 by s square plus 9. Use the formula derivative of u by v, that gives L of t sine 3t. In t sine 3t, put s is equal to 2. We get third problem. So the first one is from first concept and third from the second concept. So try to read the concept, read the methods, then practice the problems that we covered in the video lesson, then try to do the homework. So if you are unable to do the homework, that's if you are having any doubts what to do, for any queries, mail me at naresh.debody@gmail.com. So read the concepts, practice the problems that we solved here, all the 8 problems in first concept, 3 problems, second concept, 5 problems, total 8 of them. Practice them, then do the homework problem. Then if you do homework problem, then post it in our Google Classroom so that I can verify and quick response. You just post me in Google Classroom, and any queries you can mail me, or you can also post in a Google Classroom. So with this we are able to cover all Laplace transforms we completed. So in next class we are going to start the new lesson. So solving homogeneous and non-homogeneous differential equations. So we see in the next class. So with this we are able to complete the topic Laplace transform. We will able to get 26 marks from this chapter. So be careful guys, practice more and more this concept so that you can able to score more marks in semester end exams. Okay. So thank you, that's all for today. Thank you very much. Stay home, stay safe, stay healthy. See you guys, bye. See you.